Hi, this is Calandra. In this video, we're going to cover an application that deals with distance, rate, and time. Suppose a couple goes on a dinner cruise. The boat traveled downstream 40 miles and then returned. If the speed of the river current was 1.5 miles per hour and the total trip took 3 hours, find the average speed of the riverboat relative to the water. Round your answer to the nearest tenth if possible. So when you have a problem that's involving a distance, a rate being traveled, and the time for the trip, we have a formula that relates these three quantities together. And that formula is distance is equal to rate times time. Now, depending on the problem that you're given, you may need to alter this equation a bit. For example, you may need to be able to figure out what your rate is equal to. Well, if I divide both sides of this equation by t, that would leave me with my rate r. So for example, when you're driving miles per hour, that's just a ratio of distance to time, so that will give you your rate. Let's say that we needed to figure out what the time was equal to. Well, if we take that original formula, divide both sides by the rate, we would have that distance divided by the rate is equal to the time. So as long as you remember one version of your formula, you'll be able to get any other version that you might need. So when approaching this type of problem, I like to set up a table. So I'm going to have columns representing distance, rate, and time. And then I'm going to have rows that represent the two conditions of my trip. So for this trip, we have a couple is traveling downstream. Which means they're flowing along with the current. So the current's going to propel them faster than the boat would normally go if the water were still. And then when they return, they'll be going upstream. So you may have heard the expression that somebody is swimming upstream, meaning they have a hard time. That's because you're going against the current, so that's going to slow them down a bit. Okay, well now let's fill in what we know. We know that the boat traveled downstream for 40 miles, and then it returned, which means it also went upstream for 40 miles. We know the speed of the river current was 1.5 miles per hour. That's not the speed of the boat, it's the speed of the water. And we have that the total trip took 3 hours. We're trying to figure out what is the average speed of the riverboat. So let's assign a variable to that. So let's let x represent the speed of the riverboat in still water. Okay, so if my boat travels x miles per hour in still water, and the river current is 1.5 miles per hour, then when the boat is going downstream, you would take its speed and add to it the speed of the current, which is going to make it go faster. So we'll have x plus 1.5. Similarly, when the boat returns to go upstream, we start off with the speed of the boat, but the current is going to slow it down a bit. So we're going to subtract from it 1.5. Well, the last bit of information that we haven't used yet is that the total trip took 3 hours. But I don't know how that's divided among the downstream trip and the upstream trip. So this is when we're going to use our formula where we have t is equal to distance divided by rate. So for downstream, I know that my time can be expressed as 40 divided by my rate of x plus 1.5. For upstream, my time is 40 divided by x minus 1.5. So what happens when we add those two times together? we know it should total 3 hours. So that will give us our equation. So 40 divided by x plus 1.5 plus my time upstream, 40 divided by x minus 1.5, will equal 3 hours. So now we have our equation to solve. Now this equation is called a rational equation, where we have variables in the denominator. To solve this type of equation, we need to get rid of the denominator. And the way that we're going to do that is by multiplying each side of the equation by our least common denominator to get them to cancel out. So let's start with our first denominator, x plus 1.5. If I multiplied my left side by x plus 1.5, that would make the denominator in the first fraction cancel out, but it would not cancel out with my second fraction where we have x minus 1.5. So that means I'm going to need to multiply by that denominator also. Okay, so whatever we do to one side of the equation, we also have to do to the other. So on the right, we multiply by x minus 1.5 times x plus 1.5. And now we need to simplify. So make sure that you're distributing that product to both fractions. When you multiply the first fraction by that product, the x plus 1.5's cancel out and will leave us with 40 times x minus 1.5. In my second fraction, the x minus 1.5's cancel and will leave us with 40 times x plus 1.5. On the right side, we can go ahead and use FOIL to get rid of those two sets of parentheses. So first times first is x squared. Outer times outer is 1.5x. Inner times inner is a minus 1.5x. And last times last will give us a minus 2.25. And those 1.5x's are going to cancel out. Okay, now I need to distribute the 40 to get rid of our parentheses. So we will have 40x minus 40 times 1.5 will give us a 60, plus we'll have another 40x, and this time 40 times a positive 1.5 gives us a plus 60, equals, okay, well now I need to distribute my 3, so we'll end up with 3x squared, and then negative 2.25 times 3 gives us negative 6.75. Well, notice on the left that the 60s cancel out, and we'll be left with an 80x. I have a quadratic equation, so I know I'm going to need 0 on one side. So I'm going to subtract the 80x to the right side. And then we'll have our quadratic equation to solve. So let's identify our a, b, and c. So we see that a is 3, the coefficient of x squared. B, the coefficient of x is negative 80. And c, the constant, is negative 6.75. And I'm going to use the quadratic formula to solve this equation. So quadratic formula says we take the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So the opposite of b will be a positive 80 plus or minus the square root. When you square anything, it's going to be positive. So negative 80 squared will be 6,400 minus 4 times, and we have a, 3, times a negative 6.75 is negative 20.25. all divided by 2 times a. So 2 times 3, which is 6. Okay, so now I need to simplify my radicand. So I'm entering this in my calculator in one step. 6,400 minus 4 times negative 20.25 gives me 6,481, all divided by 6. Okay, so now we're ready to get our two answers. So we'll have 80 plus the square root of 6,481 divided by 6. And then we'll have 80 minus the square root of 6,481 divided by 6. So to put that in your calculator in one step, remember that you need parentheses around your numerator before dividing by 6. And let's see, the problem tells us to round to the nearest tenth if applicable. Okay, so in my calculator, I'm doing open parenthesis 80 plus the square root of 6,481, closing my parentheses, and also for my square root, because my calculator gives me an extra one for the square root. And this is approximately 26.8. Okay, when I put my second value into my calculator, that gives me approximately negative 0.1. So let's see what our x represents again. X represented the speed of the riverboat in still water. Well, we're not going to have a boat with a negative speed because it would be traveling backwards. So that means the 26.81 is a value that we want, and our units are miles per hour. And let's make sure that we've answered the question. Find the average speed of the riverboat relative to the water. So we know it's traveling 26.8 miles per hour in still water. So to figure out its speed going downstream, we would just add 1.5 to that amount. And to find the speed of it going upstream, we would subtract 1.5 from that amount.